Number 3 should look familiar.
Yep.
Number 3 was straight off the test. Everybody had number 3. Because remember, I think it was Tara that asked, will there be one like that on the test? And I smiled and said probably. And there it was. It was this one. Okay?
Who would have known? What?
So, when you have an expression that is both a difference of squares and a difference of cubes, you must do the difference of squares first. Well, it's not a must, but it's the only way we notice that what we have left is still factorable, is if we do the difference of squares first. All right, so number 1 was not a biggie. It had a GCF. It was a perfect square trinomial. Number 2 was a higher degree polynomial function that's in quadratic form. So because this is cubed and this is 6, we can go cube and cube. So x cubed times x cubed is x is 6. We're good. Now, this part is done. It does not factor anymore. This factored further. Okay? How is 2? We good with 2? All right, so number 3 was the one that was, I would put it up there. It was a missed problem on the test. Now, you got half credit if you made it there. I thought that was generous. You were halfway done. So it factored once more. Okay? So, if it's something we missed on the test, and it's something I put in the warm-up, and we've talked about it multiple times, it will probably come back.
Can you just put this one on the test?
No, we can't put the exact same one, but it'll be similar.
I definitely
I feel like it's possible.
I definitely think that like if
Or should everybody agree?
you tried, I think you could.
Alright.
Oh, you know what would be a different one? 62.
If you tried really, really
62
hard.
wouldn't factor it off.
No, I'll just make it
That's kind of perfect.
Yeah. One question.
Alright, I hear you. Alright,
Negative in there.
Negative 1 plus 1.
so yesterday I didn't get through the entire lesson. If you notice, there were 4 questions at the bottom that I didn't ask you to do. And one of them we kind of talked about. How can we tell if something is a factor? So, what do we know the remainder is if an expression is a factor?
0.
0. So we can do synthetic division. What sits on the table?
3.
3. All right. What goes here?
1.
And then? I heard negative 1. And then?
Negative 5.
And then?
Negative 3.
Okay. So let's remind ourselves what synthetic division is, how we do synthetic division. We always bring down the first one. We multiply. We add. We multiply. We add. We multiply. We have a little party because it is 0.
Oh yeah.
Okay? So that was a little odd. So this is a factor. X minus 3 is a factor of the this expression. X cubed minus x squared minus 5x minus 3. Okay? Now the cool part is we can actually, now that we know this, we can factor this completely because this is plus x squared, right?
Yep.
This is the expression x squared plus 2x plus 1. It is a perfect square trinomial. The factors 2, x plus 1. So we can actually find all the factors now. We know in completely factored form, this would be x minus 3 times x plus 1 squared. And then I can ask you to graph it. If we thought of it as a function. Alright, now, another way. And this is what was at the bottom of your sheet. Okay? So, remainder.
Yes, sir.
If the remainder is 0, we know it is a factor. So this is the factor theorem. We know this is a factor of this expression because the remainder is 0. Now, there's a remainder theorem, and it says if this were given to us as a function instead, like this. If it was given to us as a function, and they said, is 3 a root of the function f of x? So what we would do to determine if it's root, Another way is we can plug the 3 in. So 3 cubed minus 3 squared minus 5 times 3 minus 3. This is 27 minus 9 minus 15 minus 3 minus 18 minus 9 is minus 27. 27 minus 27 is 0. Guess what this 0 means? The same thing as this one. Okay? This means if I did synthetic division, my remainder would be 0. When I evaluate this function for 3, I get out 0. If I get out 0, that tells me it's an x-intercept. It is a root of the function. So yes, it is a root. Okay, so this is what we didn't get to. All right, so 21 and 23. These were the two I didn't ask you to do. I said 1 through 19 odd. So this says P of x is x squared minus 1. Determine if the given value is a root. So when we plug in 1, we get 1 squared minus 1 is 0. Is x equals 1 a root of this polynomial? Yes. X equals 1 is a root.
You just plug it in.
You do. You just plug it in. All right, you try 23. You may use your calculator.
So
You
this year
certainly
that
may
we
use your
can.
calculator. This next test will have a big calculator part.
Yeah.
Yeah.
Not the whole thing.
Maybe not the whole thing. I'm
Are you
gonna,
gonna have tests that have the
I'm
whole
gonna
thing?
keep you sharp. You guys are to the age where you're about to take the ACT and the SAT.
With the
Parts have a calculator, parts do not.
Majority is calculated.
Not of the SAT.
Oh,
the
got
ACT,
you.
I was
Yeah, I
the
think
SAT.
They did-
I got
they did
none
change
on my
it.
ACT,
I know.
Did you get 2 calculator sections and 1 non?
No, but like it wasn't like there were more questions in the calculator section.
Yeah. But you still gotta get those in the no calculator section right.
Yeah.
Yes.
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 But then after that,
Then it's useless. So I think I should use calculator.
Are there still like on the SAT that we won't learn?
Are there things on the SAT that we will not cover this year? Yes.
oh,
Actually, I'm pushing really hard for May covering the unit circle. So we should get there. So by the end of this year, I did work with the county, and there were 3 or 4 topics that were not in Algebra 2 that are on the SAT and ACT. We've added them back. You'll see them this year. Operations with rational expressions and solving rational equations was just a pre-calculus topic. I stole it back for Algebra 2. Then direct and inverse variation we'll do. We will do some unit circle. We will talk about some parts about trig. You know, so far you guys only learned about sine, cosine, and tangent. Well, there's the reciprocal functions also. Secant, cosecant, and cotangent. You guys haven't learned about that, and that's a senior level only topic that needs to be in Algebra 2, so we're pulling that back down. So this year we're doing more in Algebra 2 than they have before, but it's needed. You guys need it before you take the SAT. It's not fair for you not to see it. And every other state in the United States teaches it before 12th grade. That's not right to you guys, so we're fixing that here at Starsnell.
what about with the ACT? How much is it?
Same stuff.
It's okay.
Yeah, so I watch the release test from the SAT and the ACT every year and look and see what's missing from our curriculum, and I make sure it gets put back in.
That's good. It's good to know somebody's watching it.
Somebody's watching out for you, that's right. All right, so when we plug in 3, we get 4 times 3 squared minus 2 times 3 plus 3. So 9 times 4 is 36, minus 9 plus 3 is not 0.
It's 30.
Okay?
No, it's not.
So, since it's not 0, is it a root? Not a root. Not a root. Okay? Alright, what is this equal to?
I was right.
Wouldn't that be 6? Minus 6? 'Cause
Yeah,
you have
it's 6.
36.
It's 6.
There we go. 33. You are correct. All right. Questions about that? Okay, let's check your homework. All right. There weren't too many that you had to do long division on. Number 5 is really blurry, but that's all right because I did that as an example yesterday. So you should have a nice corrected number 5 already.
Wait, Mr. Williams, the reviews that we turned in, are we getting like points for that? Is that like a
Okay,
grade?
I actually, you got 2 grades for that review. The first grade was, did you do it in the first place? The second grade on the review is, did you make corrections? Yep. So there are
So is it
2
like
grades
one
on
more
every review. Did you do it and did you make corrections?
So we're gonna run it at the review,
Every big test review, yeah.
like unit test.
What you said, did you do like checking for accuracy too?
Well,
Well, I was
on
wondering.
the, yeah, once you turn it in, every single problem should be accurate.
I'm just making sure because I'm pretty
Yeah,
sure
Technically,
all
if you do corrections in your.
Well, one person said, I didn't miss anything,
I think.
which is fine. Just put check marks and ready. Makes it really easy for me to see.
Well,
Never mind. I get that's
Never mind. Okay.
And then what happened last year was people started faking me out. They would put check marks on things that were completely wrong. So then I had to give them a 0 and write them up.
That's
Terrible.
like actually really stupid to do.
Well, in that line?
Yeah.
But what if they like?
Not only that, but it's like.
what if they like got on the wrong question?
Yeah, I
And
don't-
they're
I
like,
mean,
oh, I accidentally messed it up, and then you
I
gave
mean,
me.
I can see writing them up if it was like 6 problems, but if it was just like, this last one.
All right. Yes, sir. Sure. I really only had issues with repeated.
Yeah. If it was the same kid that's doing it
Yeah.
like 80 times, I'd definitely.
I'd write him up. I'd send him up to Mr. McBride. Mr. McBride is.
We good?
Yeah.
Yeah? Good? Good? Yes, ma'am. Can we Band-Aid?
No, I'm good.
Yes. All right, you do.
Why would you add zeros for?
Okay, so whenever we do synthetic division and we are missing terms, anytime we are missing degrees, you have to put in the placeholder for that. So like in number 9, we have an x cubed, we do not have an x squared, we do not have an x, and then we have a number. So what we have to do is where the x squared would be, there's actually 0 x squares. And there are 0 x's. So when we do synthetic division, you must put the zeros in as placeholders for the missing degrees. Otherwise you get a wrong answer.
So, just
Like big numbers like 30s.
Yeah, you get crazy numbers. Yes, ma'am.
So like if you put it in the placeholders, why is it number 1?
Well, number 1 doesn't have anything missing. It goes 2, 1, x to the 0, nothing.
So it doesn't have to have.
Right, only if it's missing. So this one's not missing any, this one's not missing any, this one's not missing any. This is the first and the only one on 1 through 9 that was missing some degrees.
If it skips one.
we can do the table method with all them put number 5, right?
Correct, and I did number 5 for you.
Yeah.
All right, okay, so use synthetic division, and is it a factor? factor? Yes. Remainder is 0. Remainder is 0. Yes. Remainder is 0. Yes. Remainder, not 0. No. Remainder, not 0. No. Okay, so we've done the odds. What are the evens due? Tuesday. Evens due on Tuesday. Some of you did them all. Have a great weekend. You won't have math homework. It's fabulous.
Wait, so
Okay? Yes.
So if we know how to do like the synthetic division like really well, like we'll be fine. Like if we don't know how to do
Synthetic
the
is
other
mainly
one,
what we're concentrating on. The test will have some long division on it, but not much.
like one,
Like
or
one.
two. Okay.
Like a small one?
A small long.
No, it'll be
division.
one that's it'll be one that works with long division.
8 divided by
It'll be one that you cannot do synthetic with. Yes.
So like, is this for tonight, Friday, and all the way to Tuesday? This is the only stuff.
Well, no, we have five problems to do tonight.
Oh, okay. That's not
All right. So you guys are good. You're good with long division. Okay. We don't need any of that. All right.
good.
Today, we're gonna learn a shortcut to expanding binomials, and it'll be using Pascal's triangle. Now, your homework is to expand the 5 problems that are on your calendar. Now, if Blackboard fails you, Willoughby World website
Will
is
never fail
always
you.
there.
It will never fail.
That's right.
I feel like you always
Okay.
have
Yeah.
It's gonna crash.
I like
With the
every,
luck-
like any night possible.
Unless there's the luck
It
we had.
would.
That's probably, you're probably right. You're probably
It'll
right.
be like there's an internet outage.
Yeah, just tonight. Yeah, that will probably happen now. Okay. So, what is Pascal's? Well, I'm not going to tell you. I'm going to let you figure it out
Why not?
because that makes life more interesting.
No, it doesn't.
Okay, so here comes the first several rows of Pascal's. I would like you to keep going. I'm not going to tell you what to do. I don't want you to tell anybody else what to do. I want you to look at the pattern and see if you can figure out what is happening and keep going.
How long do you want us to go?
Wait, is that like
2, 3 more rows.
this will be? Is that like a 1, 2, 1, or is
This
it
is
a
a-
third one?
A 1, a 1, 1, a 1, 2, 1, a 1, 3, 3, 1.
That is done.
Molly, yes.
Sorry.
No, that's not.
Oh, rats.
Can we go to 5?
Oh, not rats. Not rats at all.
Okay.
Am I doing this right?
Alright, what do you think?
It's slowly gonna expand it.
Alright. You think you got it? Okay. Alright, who thinks they know what the next row is? Alright, Carson?
I think the next row is gonna be a 1,
Okay.
and then a 4,
Okay.
and another 4, another 4, and another 4, and another 1.
Alright,
No,
I
it's
agree
not.
with this, and this, and this, and this.
Ah, okay.
Alright, what goes in the middle?
6.
6.
Oh.
You're right. Okay?
Oh, wow.
Alright, you do the next row.
Oh, shoot.
This is it. You lost me on that.
What is this?
I'm out.
What
Gotta
is
go.
this? This is some like magic.
You like what? These were not 2 people said 6. That would be
It doesn't make sense. Get it. Oh wait.
But even if I did get it, I...
Okay. So Huey and Carlos cannot answer now. But who thinks they know the next line? Alright, Kiru?
159851.
Alright, those 2 are right. Alright,
Okay.
Kara?
Is it 8 in the middle?
No? Okay.
Is it 10? 2 10s.
2 10s.
This doesn't make sense.
Alright, it's about to make total sense.
What is going on?
Okay?
What is going on?
Wait, give us one more chance.
Same, Molly.
I'm so confused. This is
Alright, so the way we build Pascals is to get ones down here, to get any number you add those two. You add those two. You add these two.
Oh my goodness.
Okay? So now everybody ought to be able to get the next row. Okay? So we're going to do it together. Ones on the ends. So we start with a 1. And then what is 1 plus 5? 6. What is 5 plus 10?
15.
What is 10 plus 10?
20.
What is 10 plus 5?
15.
15. What is 5 plus 1? And a 1 at the end.
I got Pascal.
Okay. So that is how you build it. Now let's talk about what it is and how we're going to use it. Alright. So here's one of my favorite websites. If you guys are sitting at home bored on the weekends, great place to go. It's called mathisfun.com. Alright, so on this one, it talks about some of the different things we can, well, first it talks about Pascal's. It tells us about Pascal was a French mathematician, and he started building this triangle, and it shows you how to build it. Well, that's what we just did. Okay, now it starts to show you really cool things inside this triangle. We all noticed that it was 1 down the sides, right? Either side. Did you notice that it is counting numbers next?
Yes, actually.
And then the next column is called triangular numbers. Triangular numbers are numbers that can form a triangle. Like 3 little dots makes a triangle. 6, 1, 2, 3, 4, 5, 6 makes a triangle. Those are our triangular numbers. Okay? The fourth diagonal is the tetrahedral numbers. All right. You should notice that it is symmetric. Now, this is where it really just starts getting cool to me. There's so many things that we can see when we study this triangle. The first row, the sum is 1. The second is 2. The third is 4. The fourth is 8. The fifth is 16. Do you see that these are all powers of 2? Powers of 2. Now, this is also neat to me. The rows themselves are powers of 11. The first one is 11 to the 0, then 11 to the first, and 11 to the second, and 11 to the third. Okay? All right? Now, this is also neat. I'm going to steal this page in just a second so you can see it. Okay, our squares are also in here. 4 squared is 10 plus 6. Do you see it? Okay, now, that by itself wouldn't be cool, but look at this. 5 squared is 10 plus 15. 3 squared is 3 plus 6. So the squares are in there. So y'all see them? All right, and then first period knew about this, Fibonacci. The Fibonacci sequence.
I've heard of.
I've heard of the circle thing.
I've heard of. I've heard of this name. I don't know what it is.
It does the little whirly thing.
All right, and then, oh, this is pretty. I gotta show you what it looks like. If we highlight either the odds or the evens, it makes a beautiful pattern, and watch this pattern grow.
Whoa.
Depends on how many lines we do of Pascal's.
That's sick.
Yeah, there's some really cool actual ones that people have made. Okay,
You should look that up.
That's
yeah.
actually pretty cool.
Okay, and then the uses of Pascal's. One is we can use it in probability, and I really wish we had enough time to explore this. How Pascal's can be derived from combinations. Do you guys remember combinations and permutations? Combinations,
Yes.
NCR, NPR, buttons on the calculator?
Yeah.
No? Counting
No.
principle, probability?
We did it.
You guys all did that.
We
didn't you?
did it.
Just shake your head.
Probability.
Just
Oh,
lie.
probably.
Shake your head. Yes. So we can find all these numbers that are in Pascal's using combinations, and this leads us into the binomial theorem and binomial distributions and binomial probabilities and all sorts of super cool stuff that if we had the time we'd explore. Okay, but all this lives inside Pascal's. And there's just one out to the 15th line. And then it tells us about some other things. It tells us about this peg thing, but I can't figure out why that's really pascals and why it's not just a triangular number. But interesting. Okay, so that's all the cool stuff about pascals. Well, you probably only care about how you have to use it. I understand. So, how are we going to use pascals? We're going to use pascals as a shortcut for expanding binomials. So, if we took, I'm going to do 2x plus y. Not squared. Let's do a fourth power. That'll be fun.
You go down 4 rows.
That's what we do. We go to the one that is the fourth power. And let me show you how this is really built when we're talking in terms of expanding a binomial. Pascals is an expansion of a binomial. Like the first row represents x plus y to the 0 power because anything to the 0 power is just 1. Alright? The second row is x plus y to the first. And if we raise this to the first power, the coefficients would be 1 and 1. 1 and 1. The second row represents x plus y to the second. If we squared this, it would be x squared plus 2xy plus y squared. So if we take a look at the leading coefficients, 1, 2, 2, 1, 1. So the leading coefficients are represented here inside Pascal's triangle. So if I'm doing a fourth power, I'm going to use this fourth expansion here, this row. And the first thing I do is I write down these coefficients. 1, 4, 6, 4, 1. Please do that. Okay, and the process is not difficult. It's the same way every time, but we kind of have to think of this as 2x and positive y. And so what we're going to do with that is we're going to start with this first term, 2x, and we're going to start here with the 1 and raise that 2x to the highest power, the fourth power. This is an expansion to the fourth power. So the fourth goes here, and then we go down a degree. So now that here, it would be a 3. And then here, it would be a 2. And then here, it would be a 1. And then here, it would be 0. Okay? Now we'll take the second one, which is a positive y. And we'll do that positive y to the 0. And we'll work its way back up. So the next one is a positive y to the first. And a positive y to the second. And a positive y to the third. And a positive y to the fourth. Now, each one of these, let's just make this big fat so everybody sees it. They're added. They're added. They're added. They're added together. And then I'm going to let you use your calculators. I'm okay with you using your calculators to do these calculations. They're not terribly difficult, but if the calculator would help you, like, do you know 2 to the 4th? 2, 4, 8, 16. 2 to the 4th is 16. So we do 2 to the 4th times 1. That's my only numbers in that one, right? 1 times 2 to the 4th. That's 16. And then the x has to be raised to the 4th. And what happens to a 0 power? It's like 1, so that kind of goes away. And that means that this one kind of goes away here at the end too. Because anything to the 0 power is 1. So multiplying by 1 doesn't change anything. So, when I take this binomial and expand it to the 4th power, the first term is 16x to the 4th. plus, let's do the next term. On your calculators, you could do 4 times 2 to the third. And 2 to the third is 8. And 8 times 4 is not a trick question. 32. So this you can do on your calculator. 4 times 2 to the third, 32. And then we have x to the third, y. Y to the first. Plus, now we do the next one. What is 6 times 2 squared? 6 times 4 is 24. So this is 24. The x is being squared on this one, and the y is being squared. Plus 4 times 2, 8. The x is to the first power, the y is to the third. Plus 1 times y to the fourth. That's just y to the fourth. And that is how we can expand a binomial using Pascal's triangle. So the part that Pascal's helps us with is finding all of these coefficients. It helps us to know that this is 1, 4, 6, 4, 1. Now, earlier today, somebody didn't believe me that this was a shortcut. They're like, there's no way this is the shortcut. And I guess it's just personal preference. We could do this the long way. But the long way would mean I have to take this and write it like this, times this, times this, times this. And at that point you can decide how you want to multiply. If I did this a long way, I'd probably do these two together and get an answer. And then do these two together and get the very same answer because they're the very same thing, right? So I would get 4x squared plus 2xy plus 2x plus 4xy plus y squared. And I'd get the same thing again over here. You guys do not have to write this part. And now what do I have to do?
Yes, do it again.
I have to
Same
distribute every single term in this one.
Yeah.
And then this one. And then this one. Every single term in the first one has to be distributed through the last one. And then I'd have to add like terms. I mean, I can do it. It's just a pain. Alright, so you get 16x to the 4th plus this times this would be 16x to the 3rd y, and then this times this would be 4x squared y squared, and then the next color was green, and I would get 16x to the 3rd y plus 16x squared y squared plus 4xy cubed. Then I'd have to do this one.
You're running out of room.
I'm out of room. I'll have to go this way. And then I'd get 4x squared y squared, and then 4xy cubed, and then y to the 4th. Now, I gotta go find the hand because I ran out of room. Now I gotta add like terms in this little line. Okay, so the first one doesn't have any friends, so it doesn't get added to anything. It just stands alone. Then here we have that. There's another one. Let's see if we see any more in this line. An x cubed y. Nope, there's no more x cubed y, so I put those two together. So that's 32x cubed y. And then I'll keep going down the line. Here is an x squared y squared, an x squared y squared. Let's see if there's any more. Oh, there's another one. You'll see it, 4x squared y squared. So 4 plus 4 plus 16 is 24. Alright, then I've got this 4xy cubed, and a 4xy cubed makes an 8xy cubed, and then I've got a y to the 4th at the end. Let's see if I got the same thing.
You did.
I did? Cool. I got the same thing. It just took, like this is 2 steps, this is 1, 2, 3, 4. So it's sort of a shortcut. Okay? Alright. So I'm going to open up my website right now. I'm going to kind of cross my fingers that it'll open. And look at that. That's success. Algebra 2. I'm not even going to try to open up Blackboard. Oh, I even got the scroll bar this time. Earlier today it wouldn't give me the scroll bar. Alright, so I'm going to steal this homework because this is your homework. New page, partial, right here. Alright, and I'm going to make it big because that's way too little. And you guys can just write those 5 down. Alright.
Just write them down.
Yeah. The only one that has an even slightly big number, I just ask you to cube it. That's it. And you're welcome to use your calculators. And those are your 5 homework problems. That's it. And please use Pascal's. And so you've got about 7 minutes left in class. You should get at least 1, maybe 2 done. And we'll call it a day.